Okay, today we're going to move right on to least common multiples. Least common multiples. We've been working on greatest common factors. Now we're going to move on to least common multiples. We're going to be looking at page 577 and 578 in your book. So take a minute to get to 577 and 578 in your book. Just like with greatest common factor, there's two methods for finding least common multiple, and I will show you both of those now. A multiple is really just skip counting. So a multiple is any number that you can come up with when you multiply a base number times another number. So your book gives it a definition of a multiple is a number. A multiple of a number is a product of the number, which I'm calling the base number, and any other whole number. Multiples that are shared by two or more numbers are called common multiples. So when we think of it in terms of skip counting, okay, I know we all know how to skip count by threes. So 3, 6, 9, 12, 15, 18, 2, 4, 6, 8, 10, 12. Well, if you think about skip counting, what is 2 as a multiple of 2, but 2 times 1? And 2 times 2 is 4. And 2 times 3 is 6. And 2 times 4 is 8. And 2 times 5 is 10. So those are multiples of 2 because they can be made where they are a product of 2 times another number. So the least common multiple is the lowest number, the lowest multiple, the lowest product that 2 or more numbers share. So let's take a look at example 1. Tom hits golf balls at the driving range every 3 days, practices putting every 4 days, and goes golfing every 6 days. If he did all 3 activities today, in how many days will he do all 3 activities again? So we want to know the least common multiple of 3, 4, and 5. The least common multiple of 3, 4, and 5. So let's look at the multiples of 3. 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, 3 times 7, 3 times 8, 3 times 9. Okay, let's stop there. Okay, now let's look at, let's look at 4. 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, and now let's look at 6. 6 times 1, 6 times 2, 6 times 3. Okay, you might notice if you have your multiplication chart in front of you, if you look at 3 over on the side and you follow along that multiplication chart, these are the numbers in the row: 3, 6, 9, 12, 15, 18. And some people ask, how do I know how far to go? Well, I've stopped here because I've already noticed that these 3 numbers share something. And what they share is a very poorly written, because it's hard to write with this pen. 1 here, 1 here, 12, 12, and 12. They all have a 12. They don't all have a 3. 2 of them have a 6, but not this one. They don't all have a 9. They don't all have an 8, but they all have 12, 12, 12. Now, there may be other numbers that they have in common, but remember, I'm looking for the lowest number they have in common, which is 12. So Tom will do all 3 of these activities again in 12 days. Well, that's a much better 2. Okay. Now, moving on. Good. And there's your answer for that. Okay. Now for checking, it says, basically all they've done is they've made a number line here, and he practices putting every 4 days. So they've put a P for putting on 0, 4, 8, and 12. They've put a G for playing golf every 6 days, 0, 6, 12. And then they put a driving, driving for the driving range every 3 days, 0, 3, 6, 9, 12. And the first place that all of these happen together on day 0. But you can see this is a driving day, a putting day, a driving and a playing around a golf day, a putting day, a driving day. And then on day 12, they all 3 happen again. So the next time all 3 of them happen are on day 12. Okay? Okay, so we've already decided that a multiple is a number that is a product of the number and any other whole number. Multiples that are shared by 2 or more numbers are called common multiples. The least common multiple is the least multiple other than 0 that's common to sets of multiples. Okay, now here's the other way to do it. And you may be thinking to yourself, this looks a whole lot like greatest common factor. Well, it does. You factor the number just like greatest common factor. So let's go back to writing tools here. Okay, how do we factor 15? They've already got the 3 and the 5. These are primes, so we're done. 4 times 10 would be 40. 4 would be 2 and 2. 10 would be 2 and 5. So the prime factorization of 15 would be 3 and 5, 2, 2, 2, and 5. Okay? All right. And there's the answer page for you. Now what we do is we write these out. 3 and 5. 2, 2, 2, 5. And then we find the product of the prime factors using each common prime factor only once. Okay. So these both have a 5, so I'm only going to use 5 one time. That's the only thing that they all share. So everything else stays. So I take 2, 2, 2, there's a 3, and a 5. Now remember, I only write 5 once because these are common, so this becomes just 1 5 right there. And then I keep the 3, and I keep all these 2s. And so it's 3 times 5 is 15, times 2 is 30. 30 times 2 is 60. 60 times 2 is 120. So the reason that this is helpful is because I really don't want to sit and write the factors of 15 all the way to 120. I really don't want to sit here and write the factors of 40 to 120, even though it's just 40, 80, 120, but 15 gets a little more complicated. If I can just factor them, multiply all the different numbers together, but if they have a common factor, only count it once. Okay? All right, so let's take a look at, there's that one. And let's look at find the least common multiple of each set of numbers by first listing non-zero multiples of each number. So in this one, they want us to list it, and they don't want us to add 0. So let's list it. So we've got 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. Now I'm going to stop there because I've already peeked ahead at the next number, and counting by tens is super easy. And I already know that it's got to end in a 0 because skip counting by 10 is 10, 20, 30. So when I saw that 30 pop up right there, I knew, hey, this is going to work. That's why I stopped. So the first number that they both share is a 30. Now you may be asking yourself, what if we did it the other way? Would we still get 30? And the answer is yes, because here's 2 times 3, 2 times 5. So the factors of 6 are 2 and 3. And the factors of 10 are 2 and 5. They share this 2. They both have a 2, so that's going to become just 1, 2 times everything else that's different. A 3 and a 5. 2 times 3 is 6. 6 times 5 is 30. So it works. All right, now it wants us to find the least common multiple of each set of numbers by first listing all non-zero multiples. So listing means we're making a list. So 3 times 1 is 3. Oh, hello, that was bad. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. Okay, I'm gonna just kind of stop there for now, do some 4s and see if we get something. No need to make a whole big long list. If you can just do a few, try the next one. Nothing common, go back and do some more, try the next one. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. Look at that, 12 and 12. The first number that they both have is 12. So the least common multiple is 12. And there it is typed out. Okay, independent practice. So you can do this either way. You can either make a list or you can do the factor tree. Let's do the factor tree on this one. The first thing I notice is this is really easy because 2, push the right buttons here, 2 can't factor any lower. You can't make a factor tree because that'd just be 1 and 2. So 2 is prime. 13, you also can't factor. It's prime. So the factors of 2, 2. The factors of 13, 13. Multiply them together. The first number you're going to get that they both share is 26. So you could do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. And then 13 is 13 times 1 is 13. 13 times 2 is 26. Let's look at 7 and 9. So 7 is prime. Can't factor it down. 9 can be broken down into 3 and 3. So the factors are 7, 3, and 3. Now this does not just become 1, 3. Because the only way that would work is if it was a 3 on the top row and a 3 on the bottom row. Then they would just combine to be 1, 3. But because these are on the same row, they both stay. So 7 times 3 times 3. 3 times 3 is 9. 9 times 7 is 63. You might notice that if you just multiply 9 and 7 at 63, that doesn't always work. It's not always that the least common factor is just multiplying them together, or least common multiple is not always just multiplying them together. Okay, so let's look at 2 and 10. Well, 2 is prime. And 10 would be 2 and 5. Now this is one of those examples where we have a 2 here, but then we also have 2 and 5. So this would be a time where these two would combine to make 1, 2 times 5, 10. Okay. So 26, 63, 10. Okay, independent practice some more here. Okay, 12 and 15. So become 3 and 4, 2 and 2. So 2, 2, 3 for the prime factors of 12. 3 and 5 for the prime factors of 15, so it'd be 3 and 5. Now, these threes combine because there's one in the top, one in the bottom, so that's just 1, 3 times 2, 2, 5 times 2. Okay, 3 times 2 is 6. 2 times 5 is 10. 6 times 10 is 60. Or 3 times 2 is 6. 6 times 2 is 12. 12 times 5 is 60. Okay, let's look at 16 and 20. 2 and 10. 2 and 5. 4 and 4. 2 and 2. 2 and 2. So this is 2, 2, 2, 2 for 16. And then 2, 2, 5. 2, 2, 5. Okay, so you might see automatically that these 2's combine to make just 1, 2. These 2's combine to make 1, 2. And then nothing else combines. So it's times 2 times 2 times 5. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. That's it. Okay, last one. 3 and 8. Well, 3 is prime, so that's it. 2 times 4. 2 and 2. So it's 3, 2, 2, 2. Nothing cancels out. So 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. That's it. $60, $80, $24. Okay, now these are